What's up, everybody? We have 10 minutes here with Mr. Nick Laufenberg to discuss angles. And don't worry, this is going to be more fun than your old high school geometry class because these angles are related to shooting. And whether you are a PRS, long-range competitor, recreational shooter, or even a hunter, this may be stuff that you want to know about in order to increase your potential accuracy or decrease your potential for error downrange. So, Nick, angles in shooting. Now, one thing everybody's going to notice if you're watching on YouTube, the old giant monitor is back. We bring that in on occasion. We have digital media to display here for you. And right away, off the bat, we see back here the Rifleman's Rule. This is one that probably everyone thinks about when they think about considering angles when they're shooting. And even archers think about this one a fair amount too. Which is the horizontal component distance. That's like where you're shooting at an upward angle or a downward angle, and you're taking the actual linear distance, rather than the angular distance. Can you go into this one a little bit for those not familiar?
Yeah. So if anybody uses one of our rangefinders, especially, I know that other companies use different terminology, but we use horizontal component distance. And if you pick up one of our rangefinders, you can change it between a couple of different modes, one being horizontal component or HCD or LOS, which means line of sight. So what horizontal component distance is actually referring to is the distance that gravity is actually affecting the bullet. Gravity is a downward force, so if you're shooting uphill or downhill, it's still only being affected for the distance that it's perpendicular to the force of gravity.
Yeah, the horizontal.
Which is that green line there, the horizontal component distance.
Yeah. Like if you were shooting, for example, from, let's say, I know one people talk about a lot, like archers will talk about this one's up in a tree stand.
Yep.
They will take the distance from basically the base of the tree to the deer instead of the distance, you look at like a right angle. So I am going to go back to high school geometry class here for a second, but like a right triangle, and there's the hypotenuse, which is the longest edge, which is that diagonal edge from the two vertical, or the vertical and the horizontal lines. Rather than taking that line, we're taking the straight line again from like the base of the tree to the deer. Or if you are shooting longer range or things like that with a rifle, maybe you're shooting downhill or even on a mountain, perhaps, or up a mountain, something like that. And it's basically, it's like you're saying, gravity is only affecting. It took me forever to actually figure out this one until people started talking about gravity.
Yeah,
gravity only works down.
Yeah, if you actually, I could have probably added into this graph here, but if you would imagine, I should have put in some arrows just going straight up and down to represent gravity, so you get a better handle on the fact that only that line going perpendicular to the force of gravity is actually affecting the bullet. Yeah,
and even though you're shooting up or down, the thing that you're actually worried about is the bullet's drop, and that's where I remember always getting confused because I thought, when I'm shooting up, am I going to shoot under the target? And when I'm shooting down, am I going to shoot over the target? Because then, if I'm shooting at a downward angle, I'm increasing drop because I'm shooting down, so I'm adding to what gravity will be doing. And I made it way too complicated, when in reality, it's just, no, we're talking about drop vertically only.
Yeah.
And gravity is only affecting the drop.
Yeah, when we're talking about any type of logical range shooting, there are effects. Shooting up or down, but those effects are almost not measurable. They're very tiny, so we can just completely write them off. And that's where kind of the Rifleman's Rule comes in, because it's a good rule of thumb to try to figure out the distance that gravity is actually affecting the bullet. So if we look at this example here, what the Rifleman's Rule actually is to calculate it, what you're doing is taking the line of sight distance and multiplying it by the cosine of the angle. So if let's say that this is the shooter here and the target's up there, or shooter here, target down there, you're taking this distance and multiplying it by the cosine of that angle.
Okay.
And what that does is gives you this new distance. So what you would do is you put that distance into your ballistic calculator, and that's the number you would run with rather than the line of sight.
Now, I thought I remember at one point in time, and I thought I remember Paul Neese was saying something like real long-range shooters actually will prefer to use line of sight. Is that right? Or is that...
So when we start getting extending ranges, increasing the angle size itself, The Rifleman's Rule becomes less and less accurate. What we would tend to look at then is more along the lines of the improved version of the Rifleman's Rule, which is super simple. Rather than taking the line of sight distance and multiplying it by the cosine of that angle, we take our dope and multiply it by the cosine of that angle, and that's all you have to do, and you get to what's called the improved Rifleman's Rule, and it's actually quite a bit more accurate.
The dope being the mils or MOA value that
Correct.
you've been given. Oh, okay. And that's for the line of sight distance. So you would range the line of sight distance and plug that into your ballistics calculator to get mils or MOA
Correct.
that you're supposed to dial into the rifle scope, and you multiply that by the cosine of the angle.
Correct.
So then when like a rangefinder like ours, you'd push the button when you're on LOS mode, and even though it's giving you the line of sight distance, it will still give you the cosine angle too.
It'll give you the angle, yep. And
Yeah.
then you can, if you know your cosines, or if you have a calculator, most calculators you can just go ahead and click cosine, type in or hit the angle, or the let's say you're shooting at a 10-degree angle, you put cosine 10 equals, and it'll give you a number, and you multiply that by your dope, and that's your new dope.
Beautiful.
Yeah.
Okay. Well, as we already figured, too, Nick and I were talking before this, we're going to go over 10 minutes, and that's fine. You guys are used to it. We've gone over 10 minutes a lot lately. So anyway, one thing that people don't consider, so there's an angle right there, vertically speaking.
Yep.
One that people don't consider a lot is sort of this angle around the axis of the barrel, if you will.
Yes.
Where that is tilting or canting your rifle to the right or left, which can impart error downrange, right?
Yeah, it can actually impart quite a bit of error. If you can go to the next slide here. This is an example of a 1 MOA target at 800 yards.
So the one MOA target's a yellow circle here, right?
Yes.
Okay.
And so I included the actual size of the target being 8.376. It doesn't really matter all that much. The important thing to consider is that this is with a 2-degree cant. You're going to hit both to the right. I mean, if you're canting your gun right, you're going to hit right and you're going to hit low a little bit. The vertical effect is much less than the horizontal, but it does still exist. But in this case, a 2-degree cant will make you miss your target.
2 degrees isn't that much.
Not much, no. So if you spend a lot of time in the field shooting and you put like a digital level on your gun, you'll notice that anything inside of 3 degrees is pretty hard for the human eye to pick up. That's if you're shooting off maybe a flat platform, a bench, something like that from a prone position. Usually you can pick up anything outside of 3 degrees pretty easily. Where it becomes pretty difficult, though, is if, let's say, you're shooting off of a barricade or shooting off of a tree or a stump or anything where you don't have an uneven platform or do not have a clean view of your horizon. And a lot of people use the horizon because your brain is pretty good at leveling stuff out if you can get your bearings on planet Earth.
Yeah, totally.
But if you're using high magnification, zoomed in on a target, guess what you're not seeing? Not seeing the horizon. Looking at trees as a reference, trees don't grow straight up. You can look at a fence post, but a lot of times those aren't pounded straight in.
Oh, yeah.
So it's really hard to use external references to get you super precise as far as your cant angle. That's where bubble levels come in. We make a couple of bubble levels that are super handy. That's what I use. There's also digital bubble levels that you can put on your rifle. But in this case right here, canting your gun by 2 degrees will send you completely off target.
Holy smokes. And how often now, I know like when I've shot, the Vortex Extreme, or I've shot just recreationally, the targets are a little bit bigger than 1 MOA.
Yep.
How often for you guys though in PRS is a target like a 1 MOA target? Is that
sometimes
very often?
they usually hang out around the 2 MOA size, which actually the next example is exactly 2 MOA. It's at 800 yards as well. So, and I included a 5-degree cant with this one to display if you're shooting off of an unstable platform. Maybe you're laying on a hillside, like canted looking downward. You're not going to have your equilibrium is going to be a little bit more messed up than if you were sitting on a bench or something like that.
Yeah.
So canting your gun by 5 degrees is not outside the realm of possibility. In that case, you would be missing off center by 17.5 inches.
Holy smokes. Now, before it was 7 inches with a 2-degree cant. So, in theory, you would have probably nicked that bottom right corner, in this case, canting the rifle slightly to the right.
Yeah.
At a 2-degree angle, nick that bottom right corner of a 2 MOA target. But, yeah, just 5 degrees of cant now, way out there and low.
Yeah.
That is wild.
It doesn't take as much as people really think it does. Some of the trouble is if you use certain ballistic calculators, you put in your gun cant angle, it's not going to read out the way this is showing, and that's because they're actually, I think most of them are actually just taking into consideration the amount of cant that your rifle is in comparative to your action, or your scope is in compared to your action, which is not going to be very much at all. You can cant your scope on your action and still have very accurate engagements. Where it becomes an issue is if your reticle is not plumb with planet Earth when you pull the trigger.
Oh, all right. Exciting stuff. We're going to leave you guys on a little bit of a cliffhanger there and try out something kind of new and actually have a 2-part 10-minute talk. So that one having to do with what happens when you cant your rifle scope that you just listened to. And next up, we are going to talk about how to properly level your rifle scope, something we all do when we mount up our rifle scopes very first. So stay tuned, check out part 2, and let us know what you think.